So next we'll discuss the derivation for the expression of mean free path. But before that we'll discuss one topic, which is sphere of influence for gas molecules. Okay, so suppose we have one gas molecules, okay, whose radius is sigma by 2. So radius is sigma by 2, therefore diameter is sigma, and the gas molecules are considered to be solid hard sphere. So this is a gas molecule which is like a solid hard sphere, and it has a radius sigma by 2 or diameter sigma. Okay, so now suppose we have one such gas molecule whose radius is sigma by 2. Okay, so this is the center of the gas molecule and let us name it A. Okay, now suppose there is another gas molecule, identical gas molecule B. Okay, and it is moving towards molecule A. So at this moment there is no contact or collision between molecule A and molecule B, but as the molecule B is moving towards molecule A, so eventually there will be collision between molecule A and molecule B. Okay, and at that moment what will be their center to center distance during collision? So center to center distance during collision. What will be the distance? You see, so this is the radius of, this much is radius of molecule B, which is sigma by 2, and this much is radius of molecule A, which is sigma by 2. So this total distance, their center to center distance will be sigma by 2 plus sigma by 2, which is sigma. Okay, now suppose there is another identical gas molecule C. It is also approaching molecule A, and at some point there will be collision between molecule A and molecule C, and again their center to center distance will be equal to sigma. Okay, now if you consider another molecule over here which is again making collision, identical molecule, say D, making collision with molecule A, then during collision again their center to center distance is sigma. Okay, so now what we will do, we will draw a sphere with which has the same center as center of molecule A. Okay, so we will draw a sphere with the center of molecule A as the center and taking its radius to be equal to sigma. Okay, so this is the sphere which has its center as the center of molecule A and its radius is equal to sigma. So now if you consider, and as you can see, the molecules B, C, D which are making collision with molecule A, all of them have their centers lying on this newly drawn sphere. So in 2D it is appearing circle, but in 3D it will be a sphere. We have to imagine it as a sphere because all the gas molecules are also sphere. Okay, so now if you consider another gas molecule, suppose over here identical gas molecules, say E, its center is lying outside this sphere and there is no collision between molecule A and molecule C. Okay, So, and if you consider another molecule like this, okay, whose center is just outside the sphere, then again you see there is no collision between this molecule, say F, and molecule A. Okay, and if you consider one such case where this G, okay, so this is molecule G whose sphere, whose center is lying within this sphere, then also there is collision. That is, actually it is like superposing each other. It cannot happen, but you can imagine of this kind of situation where the center of one molecule, another molecule is lying within this sphere. Okay, so you can see that if the centers of the molecules are lying either on the surface of the sphere or within the sphere, then there will be collision between those molecules with molecule A. Okay, so this sphere that we have imagined to be surrounding molecule A, and it has the same center as molecule A with a radius of sigma, is called sphere of influence. Okay, so this sphere is called sphere of influence, which has this. So this sphere of influence has radius equal to sigma. So the diameter is 2 sigma. Okay, so we can say that a molecule will make collisions with only those molecules whose centers will lie within the sphere of influence of the first molecule. First molecule means this molecule. See, in our case, the molecule A. Okay, so in our case, the molecule A. So this molecule A will make collision with only those molecules. So in our case, which molecules are making collision with molecule A? Molecule B, C, D and G. Okay, and their centers, as you can see from this figure, their centers are lying, not F, sorry, are lying within the sphere of influence. That is either on the surface of the sphere or actually inside this sphere of influence. But if you consider the molecule E and molecule F, their centers are lying outside this sphere of influence of molecule A. For the molecule E, it is quite well outside the sphere of influence, and it is for F, it is just outside the sphere of influence, but still there is no collision between molecule A and molecule F. So we can say that a molecule will make collisions with only those molecules whose centers will lie within, or you can say on, the sphere of influence of the first molecule, that is molecule A. Okay, and the radius of sphere of influence is sigma if the molecule under consideration has a radius of sigma by 2, and the diameter of sphere of influence is 2 sigma. Now we'll use this concept of sphere of influence in derivation of the expression for mean free path.